Part 3 of Bio 168 review. Last time we stopped off talking about the body planes. So remember, you have those three imaginary body planes: the transverse or horizontal, the sagittal or mid-sagittal, and then the frontal or coronal. And from those um, body planes, we came up with, or we discussed rather, the directional terms superior and inferior, lateral and medial, um, anterior, posterior, ventral, dorsal. We talked about all of those, right? Now, it's also important to understand that your body is broken down into two cavities. You have your abdominal pelvic cavity, which is going to be the front side. Then you have your dorsal cavity. The dorsal cavity is only going to consist of your brain and spinal cord. The abdominal cavity is broken into two parts because most of our organs are on this front side or this anterior side. So you have what we call the abdominal pelvic, which is the bottom. Then you have your thoracic cavity, which is your chest. In the thoracic cavity, and we can see from this slide here, in the thoracic cavity, you're going to have your lungs, your heart, and those great veins or blood vessels. In the abdominal pelvic cavity, because the vast majority of the organs are located there, what we are going to do is, or what is done is, that area is going to be divided into 4 quadrants or 9 regions. So those quadrants, you have the right upper quadrant, left upper quadrant, right lower, left lower. And then for the regions, obviously you're going to have your epigastric region, your umbilical region, your hypochondriac region. Those are there so that the physician can pinpoint where the actual pain is when we complain of pain in our abdominal area. Because most of the time, when we go to see a provider or a physician, we say, "Hey, I have a pain in my stomach," right? And this area right here. However, because we have lots of organs there, it's really hard to pinpoint where the pain is coming from. So if you notice, when they start to do any touching, they touch you here and so forth, so on, they're doing that to pinpoint exactly which quadrant or which region this pain comes from. And so you can see from this picture here that with the 4 quadrants, the vast majority of the abdominal organs are found in those 4 quadrants. We have the right upper, the left upper, right lower, left lower. Now, when we are identifying which quadrant and which region these organs are found in, the key thing to remember is that you're going to always select the quadrant or the region in which the vast majority of that organ lies in. For example, we can look at this slide. We see that the liver, the big brown thing there, is majority of it, rather, is in the right upper quadrant. So if there was a question where you had to identify which quadrant the liver is in, um, the right upper quadrant would be the best answer. Same here, if we're looking at the regions, you're going to look now to see which region holds the vast majority of that organ, and that's the region that we're going to go with. Now, depending on the instructor, they may want you to choose all of them, but most of the time we're going to go with the region or the quadrant where the organ lies or where the majority of the organ lies. So now we're going to shift gears just a little bit. We're going to start talking a little bit about chemistry. So it's important to know some chemistry when we're doing anatomy and physiology, not a lot. We don't have to go into grave detail, but it is important to understand number one, that we have these four elements that the human body needs: the oxygen, the carbon, the hydrogen, and the nitrogen. Those four elements are needed in order for the body to carry out its normal functions. Now, the purpose behind chemistry is so that we can understand those reactions that are happening within our body, because the vast majority of the chemical processes that occur in our body not only occurs within water, which is the main solvent, right? But there's also other elements and other nutrients that are needed in order for the body to perform at its best, right? So that's the reason why we need this brief understanding of chemistry, because we have to understand those reactions. So those four elements, the oxygen, carbon, hydrogen, and nitrogen, are all needed in order to allow the body to function properly. Now, to go into a little more detail when we talk about chemistry, because remember, from the organizational or hierarchy, we talked about there's the simplest is chemistry, then we got those organelles, and then the cells and tissues and so forth, so on, right? So let's take a closer look rather at these elements. Now, when we're looking at the elements, there's some atoms. The atoms are going to be composed of three things, three subatomic particles, which means these are small things that make up the atoms. We have a proton. Protons have a positive charge. Remember, positive, P positive. Protons have a positive charge. Neutrons have no charge. They are neutral. Neutrons, neutral, zero charge. Electrons have what we call a negative charge. Now, these electrons are going to be orbiting around the nucleus of that atom. Now, that atom that has the electrons orbiting around the nucleus has the protons and the neutrons inside of the nucleus. That's what's going to contribute to the atomic mass of that particular element. So that number that we see at the bottom when we're looking at a periodic table, the number that we see at the bottom represents the number of protons plus the number of neutrons inside of that nucleus of that atom. The top number that we see when we're looking at the periodic table, the top number is going to represent the atomic number, or the number of protons that are present inside of that particular element, right? So the number at the top is our atomic number, representing the number of protons. The number at the bottom is going to be the atomic mass. That's going to represent the total number of protons plus neutrons that are inside of that nucleus within that atom. So we looked at the subatomic particles. We talked about the protons having that positive charge, that neutron having a neutral charge or no charge, and then there's electrons that are orbiting around it having a negative charge. So I just stated here, the atomic number at the top is the number of protons in the nucleus. The mass number at the bottom is the number of protons plus the number of neutrons inside of that nucleus. Now, when we're looking at a periodic table, not only does that top number, the atomic number, represent the number of protons, but Only on a periodic table, that top number also represents the total number of electrons, because on a periodic table, those elements are not interacting with each other at all. They're just on the table, so they're neutral. And so the top number, the atomic number that represents the number of protons, will also represent the number of electrons, because it is neutral and it is not interacting with anything. Once it interacts with something, meaning another element, then that number of electrons can change. Speaking of interacting with others, let's look at the bonds. There are two types of bonds that we're going to talk about. The first is an ionic bond. Ionic bond, when you hear ionic bonds, just think about creating an ion. An ion is something that has either lost or gained an electron, so therefore it has an additional charge to it. For example, you see here, uh, when the when an electron is given off, meaning that it when an element gives away an electron, or an atom gives away an electron, now it has more protons in the nucleus than electrons orbiting around it. Thus, it's going to have a more positive charge, which means that it is a cation. Let me say that again. When the atom is interacting with something and it gives up an electron, remember I said that top number, that atomic number, is going to represent the number of protons and the number of electrons only on the periodic table. When it gives away an electron, therefore it's going to have more protons in the nucleus than electrons orbiting around it. So therefore it's going to have an overall positive charge and is considered a cation. Reversely, when it gains an electron, now it has more electrons orbiting around it than protons inside of the nucleus. Thus, it's going to have an overall negative charge, which means that it's going to be considered an anion. Now, with the ionic bonds are going to be given up or receiving an electron. Two different atoms, two different elements are going to either give up or receive an electron, and they're going to come together, and that is an ionic bond. So one element, one atom gives an electron to another one. This one receives it. They bond together, thus creating what we call an ionic bond. Now, the reason why this occurs is because when we look at the periodic table, even though I don't have a picture of the periodic, no, I do not have a picture of the periodic table. However, when we look at the periodic table, the far right is what we call the noble gases. That's where all of the elements want to be. They want to have all of their shells filled with electrons. Now, the inside shell that is orbiting around the nucleus can only hold 2 electrons. All of the other shells can hold 8. So that is what we call an octet rule, because all the elements want to do is have their valence shell. That valence, the term valence just means outside, the outermost shell. The valence shell, or the outermost shell, wants to be full of electrons, whether it is 2 because it's only one shell, or whether it's 10, meaning 2 on the one in the shell in the inside and 8 on the second shell. So in order to do that, elements are going to sacrifice and give up or receive electrons so that they can satisfy that octet rule and be bonded together. The prime example of that is NaCl, sodium chloride, NaCl. Sodium Na is one element over where it needs to be, one element, one electron over where it needs to be, where chlorine is one electron away from where it needs to be. They come together, they decide, hey, you know what? I'm going to give and I'm going to receive an electron. They bond together, creating what we call an ionic bond. Right? The second type of bond that we're going to talk about is a covalent bond. Unlike ionic bonds, covalent bonds have to deal with sharing electrons. These electrons can be shared equally, meaning equally between the elements, or unequally, meaning that one of the elements is going to have a charge that's going to attract the element from the other one. So now covalent can be polar or non-polar. When we say polar, that means that those electrons are unequally shared. So that means that that electron around one of those elements is going to gravitate more towards the other element than its own. The prime example of that is going to be H2O, the hydrogen and oxygen. That electron around that hydrogen is going to gravitate more towards the oxygen because oxygen has what we call a higher electronegativity. That means it has a higher affinity for attracting electrons. So that electron around hydrogen is going to gravitate more towards oxygen, thus giving hydrogen a partial positive charge and giving oxygen a partial negative charge. Because of that, those electrons or that electron is unequally shared, right? Now, when we look at non-polar covalent bonds are when the electrons are equally shared. So usually when you bond to yourself, when there's an element that bonds to itself, those electrons are going to be equally shared between the two elements. So again, we have ionic bonds where we are giving up or receiving an electron, thus creating what we call an ion that's going to have a charge on that element. If it's positive, that means it lost an electron. If it's negative, it means it has gained an electron. Covalent bonding is when we are sharing those electrons equally or unequally. If we're sharing it equally, it is going to be a non-polar covalent bond. If it is shared unequally, it is what we call a polar covalent bond. Thank you for watching. Stay tuned for video number 4, where we dive into cells and the hierarchy and the organizational structure. Thank you for listening, and I hope you have a wonderful rest of your day. And I really hope that this was informative. Thank you.